Welcome to this week's installment of the Mechanical Engineering Research Seminar. So this week we have Dr. Andrea Surovek to speak about, well, where the heck is creativity in engineering?
Yes.
Right? So let me hand it over to you, and you can probably advance the slides with doing something.
Yeah, usually the up-down button works.
Okay, thank you.
I am an absolute believer that that calculus is an important component in engineering, but that communication is more important. And I think if you look at design processes, what you're going to find is that creativity is an essential component as well. What I really am going to talk about today, I'm not a big fan of like, here is my outline slide. It may be because of the topic matter, it may just because, you know, I don't want to know the ending before I get started. But I want to talk a little bit today about a different perspective on how you think about creativity. Okay. So let's start with, you are an inspiring inventor, right? And you come up with a machine that will make food out of water, right? This is amazing. This is a phenomenal invention. It's highly technical. It surpasses everything we know about how these things are done. And you can make food for the masses, right? This is pretty impressive, right? World hunger is solved. What could possibly go wrong? Something like 90% of farms worldwide are family owned. So what happens to small agricultural economies? Right? What about the cultural significance of food? Right? Do you only produce vegan food? Do you not produce vegan food because you don't want to offend people who think that you should be eating meat? What about hunting? How about kosher preparation of food? Is this thing in the sky creating kosher food? We don't know, right? Who decides what food is being made in what location? Do better neighborhoods get better food? Right? And what happens to food waste? This is a photo directly from the movie, by the way, which I think is phenomenal. And if you're not familiar with Clouding Me with a Chance of Meatballs, it's a cute flick, but you know, what happens to all of this food waste? Obviously, not everything that's dropping from the sky is going to get eaten, right? So the answer was innovative. But what about the question? Was the question creative? Was the question well thought through? And one of the reasons I'm bringing up, we're actually currently working on a proposal. We got invited to submit what's called an EAGR proposal, which is a sort of a high risk, high reward proposal. And essentially what NSF is looking for right now is creating researchers who can conceive better questions, right? Not just better solutions, not just better ways to do things, but actually better questions with potentially transformative outcomes. So what exactly is creativity, right? We'll all agree that this was creative, right? Van Gogh was a creative dude. He was doing things that were different than a lot of people. You know, it was novel, right? It's functional in that it evokes a response or it creates a lot of income for someone, right? It's not just novel for the point of being novel, right? And one of the things that we get hung up on is this idea that creativity is somehow tied to artistic endeavors. Or so singers are creative, but engineers aren't creative, right? Sure. There are absolutely different domains of creativity, and art is not one, or is not the only one. So that block that he has in his hand, was that creative? Not only that, but it was transformative, right? I actually got to meet Martin Cooper. It was so cool. Best conference I ever went to. So I got to talk to Marty Cooper, the guy who invented, for all intents and purposes, the cell phone. And The innovative idea behind the cell phone was not a phone that could travel, right? What happened was, I believe it was AT&T at the time was working on the car phone, right? So you're out of your house or out of your office, but your phone's coming with you, so that's great, right? But you were still calling a place. In this instance, you were calling a car, okay? There was a physical space that you were making a phone call to. The transformative idea that Martin Cooper came up with is, why aren't we calling a person? It completely changed communication in the fact that if you called someone home and got their answering machine, or if you're really ancient, an answering service, I even vaguely remember party lines. Not that old, but I'm that old. So now all of a sudden, instead of calling a location, even a private location, you called a human. Right? So when somebody calls you, they're calling your phone, they're calling you. Matter of fact, have you ever called somebody and like their kid or their spouse or their roommate or something picks up and you're like, what the? Because it's not what you're used to, and that used to be the norm. Whoever was near the phone picked up. So this is considered a transformative idea. It completely changed how we think about this particular idea. So in the engineering design process, right, usually what we think about, and there are 9 billion different design processes, but if you think about like creativity, what we normally think about is creativity in conceptual design. All right, we have this problem we have to solve, and we're going to brainstorm a bunch of ideas. Have you ever had anybody bring up the idea of brainstorming at other parts in the design process? One of the places where we normally don't, and I don't know, do I have a, yeah, let me just use this little guy. Over here in problem or project identification and specification development, or back in the conceptualize area, one of the places where we need to use creativity more and more now as engineers is in idea generation. And that goes back to, what's his name, Flint Lockwood and his little machine, right? Was very creative about the output, but what was he creative in asking the question? So we can talk about invention, which is application of math and science, and we get a creative solution, or we could talk more about the problem, right? So math and science we're good at, technical solutions we're good at. How good are we at defining what other things influence the problem? And where this requires creativity is you have to start, talk about your solution bubble or your thought bubble or your design space. What about your problem space? The real questions that we need to start answering as engineers to make a difference on the planet, to lead, to really do something transformative, involve things like culture and public policy and psychology, and yes, even to a great extent, art and sociology, and a lot of things we don't normally, there's those classes you have to take as an undergrad because they make you, your electives can be more useful and more important than you might think. So I want to talk to you for a minute about the difference between complicated and complex. You're getting your master's students, right? You are learning to solve complicated problems, correct? They require a lot more technical knowledge. They're harder to solve than the stuff you did as an undergrad, in theory, right? You may have to do some programming to solve it. You may need some tools. You may need to do a number of models, but there's expert knowledge requirement. But the thing is, for complicated systems, the cause and effect, you pretty much know before your system commences. So think of a finite element model. Right? It may take you a number of times to sort of iterate to come up with the right number of elements in your model or what type of elements you're using. But that's all pretty much known in advance at this point. And if you put together a model, there is a definite thing for the solution will come out, correct? On the other, so this is the equivalent of hypothesis-driven research. I have a hypothesis, I'm going to set this in place. I know what I'm inputting. I should have some idea of what the outcome is going to be, or what it's going to tell me. Now, complex systems, the problem with them is that you don't know, if you set up a hypothesis, you really don't know how to get to testing it, right? It requires multiple inputs from different disciplines, right? Like solving world hunger. If it were simple as making a machine, we'd have done it by now, right? So this whole set of feasible solutions can't be figured out in advance because the problem has too many components and there's no from point A you can get to point Z kind of thing, even if it's multiple paths to try and get there. So this is NSF's definition of it, right? So integrating knowledge, expertise from different disciplines, novel frameworks. There are three words that are here: transdisciplinary, interdisciplinary, and multidisciplinary. Have you heard all three of them? Do you know kind of the difference between them at all, or do they all just sort of blend? You can be honest.
I don't think I understand the difference between transdisciplinary and the other two. The
Okay.
other two, I see the difference.
So I came up with essentially, this is my analogy for how this works. When you're looking at multidisciplinary work, all right, think of it as something that you've got a puzzle and you can take it apart and kind of divide and conquer, and then you have to come together at the end and put it together. And there may be some little tweaks here and there to make sure everything fits together, but for the most part, it's something that can be divided and solved. On the other hand, is interdisciplinary. There are areas of the solution that go off into different disciplines, but there's some overlap. So if you're not working with the people in the different areas, so it's more Venn diagram than puzzle, but when it comes together, it pretty much looks like what you were expecting it to. And the best way that I've figured out to describe transdisciplinary is it is interdisciplinary research, but when it all comes together, all right, the entire solution is larger than the sum of its parts. So the best analogy I can come up with this is this is actually pulling from my musical theater background, but it's essentially like pixels, right? Think of all of the pixels that have to come together to create a picture, right? So when you're think of transdisciplinary as a layer more of interdisciplinary, where everybody's working together, but those lines of demarcation get really fuzzy, all right? There's a lot more interaction, and because of it, what you can get out of it is significantly, I don't want to say better, but more complex and a larger picture than just simply layering these things on top of each other. Right. I only put in this slide just to mention that, okay, you're looking at specific and compelling problems, and you have to have deep integration across disciplines. And when I talk about across disciplines, I'm not talking about those of you in robotics and thermo, right? Got to get outside the department a little bit here. And then there are wicked problems. And wicked problems are, for lack of a more professional term, they're complex problems on crack. They are really, they're just like the worst of the bunch. So this is your design method, basically. You know, it's not some nice loop, it's not integrative, it's just, and part of it is because wicked problems involve so much contradictory opinion and information. I would say that probably the single easiest example of wicked problems in this country would be immigration. Because you can't get 4 people to define what the problem is the same way. But if you're going to be engineering leaders in the future, these are the kinds of things we have to tackle. Right? There's only going to be so many more research projects on new ways to figure out thermodynamics, right? I'm a structural engineer by training, and I swear to God, I've read more proposals on, all right, if we take this bolt hole and we now change it to 1/8 of an inch larger, what impact does that have on the behavior? People wonder why I changed, why I changed research areas. And that's called, what's the word I'm looking for? It just moves it a little bit forward. Incremental. It's called incremental research. And there's just not a lot of room for that. There are still things, yes, we need to know, but so again, wicked problems, people, we don't know the methods. We're supposed to get a solution out of this. So what I want you to do is actually talk to each other for a few minutes, okay? So groups of 3 or 4, we'll just divide the room in half here, all right? And so let's talk about this one for a minute. Just take a couple of minutes and chat, but this is about defining the problem. So we had COVID-19, right? And one of the things that COVID-19 pointed out was that there were inequalities in education. So particularly regarding like access to technology, right? Anybody, I heard about people in this state and at this school who were in their cars trying to do homework because they were trying to pull internet off of like a local business. Not exactly equal to people who have great Wi-Fi at home. So take 3 or 4 minutes, kind of group up and ask yourself, outside of just things like better laptops and better infrastructure, what are some of the things you would need to consider in solving the problem? I know I'm just supposed to talk at you for a half an hour and then you're done, but I'm going to make it work, so.
I didn't know it actually worked.
I know, right?
Yeah, I thought it would.
Well, it wouldn't be.
If I understand correctly, we're not proposing out engineering solutions, we're proposing considerations.
You're defining the problem.
Yeah, okay.
What are things to consider in the problem? Yeah. So. Well, it wouldn't be a very creative presentation if I just talked at you, right?
Play soccer.
That's true. I would say also understanding what is the inequality? Like it says highlighted it, but even whatever you want to call it. So she's talking about Wi-Fi. I'm sure there's a lot of others.
Yeah. Okay, you can run down it. Well, also, I mean, so
Yeah, so it comes back on.
well, and it's even like, what is this? Schooling. Right, I don't know how to like somebody share to the shoe factory. Social connections.
One good thing, like I think we shared our radios all of last semester.
It's like way, and then they come back.
Yeah, there's material sharing. Information sharing. This is just saying, you tell my wife, as 1 hour a day, send it to work. Offload that preparation, right? It's like you get a pet, right? Sometimes that the dog is already trained. Guess you kind of hit it. I mean, if you've got students that are living on campus, or if you've got central, parents.
direction. Imagine you're living on a reservation
Well, I think of a simpler version of that.
or
like,
living
what is
in
something
rural
that's-
South Dakota.
So I had freshmen who were living
And
across
you just
the
find
street
out
from
that you have to
their
do all your
60s.
school from
Still,
home.
they still think it's great.
What sorts of kind of issues?
As opposed to like your class, Dr. McCready, right, like you all probably live off campus, maybe some distance, with access.
What kind? Run out of paper. Maybe another insertion in which if 2 hours. Well, because you need paper to write about people because you don't necessarily solve the paper or doing that. There seems to be, like, for example, there's a lot of things going on in this part of the country. And that actually shows you kind of
You live in a little town and that's storm going back.
so
You can lose internet Wi-Fi in most of the
anytime
big
you
cities.
need to is it maybe your place?
Yeah, that probably. Reservation might do the better.
Just across the states. We could. And all over different specific desires, requirements, needs, issues.
Right. It surprises me that not all
Maybe
my
they can think of living.
Yeah,
Specifically, or those will come to, they can.
it's a fair approach. I'll do this with the other relatives, you know,
From school.
Well, no, you're fine, you're better PhD, you can join the ranks of less than you. And then we'll allow you to.
So my thing is, one of my things is the whole concept of the focus.
Yeah, that's a little bit.
Really?
The ability of focus technology.
What does that mean?
Well, I think what we've
Well,
done
that's
is,
one.
Yeah, that's what it is.
we made it, we've mesmerized.
It's very
by
hard
the
to
technology, or the advances in technology and applying it in education without thinking about the inequality and access.
It's worth bringing up.
When education was a slave job.
I know. I knew there were kids in the elementary
A
school
lot
that
more
they got
people have
their
equal
dentist appointments were at school because
When
the
we
schools
start
were not
adding
dentist
all the
appointments.
bells and whistles that
So we're not
everybody
able
wants to
to
sell us, and we start
From
using
the
all that stuff.
money income
Acquiring it all, and now we start really
general healthcare.
inequality, the access. And a lot of times, is the benefit worth it? Like, I was teaching 15 years ago when smartboards came out, right? And it was literally, it was a $2,500 whiteboard, right? And all the schools would buy this thing, and it was a big thing to have, and then you realize. And then they all turned into bricks. They all turned into bricks because they realized that the old-fashioned whiteboard was like a piece of blackboard. That's what we're efficient at doing it, but everybody trying to do it.
Right. Well, and it's also like, it emphasizes it's value, right? So everyone has a laptop, so when you're crack it open and search for answers online, as opposed to wrestling through conception.
For the sake of time, I'm going to pull it back in. Although I'm interested in hearing more about slate boards. So what are some of the things that define the problem above and beyond internet access? If you can't physically get students in classrooms.
We said like your social support structure, so it'll include like your parents, if you're struggling in a class and you can't make it to a teacher's office hours for whatever those reasons are. If you live with roommates that are in the same class, you can learn from each other. But if you live alone in the middle of nowhere, you can't. And you're not learning it, you're not gonna learn it. Or whatever, yeah.
Thomas, don't forget that we've got a Zoom audience, so we gotta project.
Oh, thanks.
Yeah.
I don't know, they might have made some insights and questions in the chat.
Okay.
So appropriateness of technology to what are your outcomes? I heard from the faculty side. so just from a previous discussion, all right, so there are different disciplines in engineering involved in solving these types of problems, but also politics matter. How your particular school district feels about education could make a difference. There's huge things going on just still right now about, do students have to mask? Do you meet vaccine mandates? Should you have parties so all your kids get sick and get immunity to it? I mean, these are actual conversations that are occurring.
Is science real? I don't know who said that. That was not.
We didn't hear anything. So how about if you're living in an area with a lot of farming, and because of COVID, your parents think that you really need to spend more time helping out because they can't get other help than doing your schoolwork online. There's always accessibility issues. How about distribution? How do we get things to people? But again, just everybody needs better internet. Does that really fix it all? There's also like teacher training. Not that anyone on this campus would have known about that. An entire group of faculty who were like, you have to teach online now. You have to use D2L? Oh my God. So, there were a ton of things that went on above and beyond simply you need a decent laptop and some internet. Not that those weren't huge. Again, hanging out at McDonald's to get all of your homework done because it's the only place in town with free internet. So the question is, how do we help you guys become engineers who are able to come up with the right problem questions and get beyond just, I can do great calculations? Because I will be really honest with you, if what you're really good at is plugging through finite element, there are a million of you per square foot in other places. What we add is this ability to get past just the rote everyday stuff. All right, so I honestly believe this, all right? But we're not as good at it. So problem number one is most of us who are of a certain age learned how to teach like this. It's basically called deductive teaching, okay? We teach you a concept, right? And then we show you a derivation. We'll discuss my theory on when and derivations are useful another time, and when they're not, okay? We show you some math. We walk you through a problem. We have you do a problem like it, right? Great, except if you have misconceptions about how this behaves in the first place, we've done nothing really to alleviate them, surprisingly. So deductive methods are great for passing along methodologies or basic knowledge, but they're not particularly good for cognitive development. The alternative to this is to give you a lot of open-ended stuff. The single thing most students hate more than anything, other than like really, really bad instructors and crappy dorm food? Ambiguity. Here's an open-ended question. Let's see how you decide to tackle it.
Keep in mind, there's only one right answer.
That's the other, in engineering, there are no right answers. There are correct solutions to portions of things that you do, but there are no right answers. Not in legitimate engineering problems. If there were right answers, we would have all been replaced by now. Things about this big. You could be an engineer on your phone, basically. All right. The engineer of 2020, which I put up here now, knowing that it's like saying 1984 was a futuristic novel, right? But the engineer of 2020 was supposed to be creative and have good communication skills, and what we like to refer to as DARF, which is dynamic, agile, resilient, and flexible characteristics. And I don't know that we did enough to really start doing this. Even the National Academy defined creativity as an indispensable quality in engineering. But there are some problems with this. No, we haven't educated the engineer of 2020 yet, but there are a couple of problems. One is that people who self-identify as creative are not all that likely to stay in engineering. Because the first couple of years of engineering are about learning a lot of like very rote methods. It's not applying novel and interesting things, right? So we keep 50% of highly creative people and 90% of those who are like, nope, not creative, engineering. Okay.
Can I ask a question about that statistic?
Yeah.
You may not know this, but what percentage of the freshman engineering students identify as each one of those things?
Oh, I don't know that offhand. I would be making up a number, but I can get you the paper.
Okay.
Elwood and Pretz is really a pretty interesting paper on all of this good stuff. In terms of what we do to divergent thinking, one of the things that we managed to help develop is something called the design fixity. So this was based on just taking freshmen and seniors and going, okay, design a new alarm clock. And what happened was the freshmen were a lot more open to the idea of just adding like lots of different things to an alarm clock. But seniors had a really solid idea of this is what this product is supposed to look like. And therefore design something that looked like that product, right? Now, that's not necessarily bad. I mean, if you know that you need to develop this product, then but what happens is we tend to, over the years, take your possible cloud of solutions and instead of expanding it, we tend to tighten it. And then my absolute, I have used this graph a lot, the scariest graph I've seen in ages. Critical thinking scores. Now we're engineers, we critically think, right? That's what we do. So if you look at freshman engineers coming in had higher scores than the normative group on campus, meaning anybody who's not an engineer, right? By the time they left, their critical thinking skills had decreased significantly, right? While the normative groups increased by about the same amount. This is problematic. Like, this is not what we're supposed to be doing for engineers. We need you guys to be critical thinkers, right? So, so how do we become more creative, right? Okay, the reasons that creativity and engineering are often considered antithetical is, for one thing, creativity requires risk. If you're doing something that's not a proven solution or that you don't already know is going to work, there is risk involved in trying to employ it. So Tacoma Narrows, do you guys have to see, in civil engineering, you have to see this video at least like 13 times before you graduate, or they don't give you your degree, I think. So if you've seen this, this was essentially it was a creative design, and yes, it failed, and it failed brilliantly. However, we learned a ton from this failure. Like, there was an entire area of dynamic response to wind loads that came off of this. The Loma Prieta earthquake in California, there were cracks that instigated at connections to beams and beams to columns in 60, 70-story buildings that went into the column. It was cheaper to destroy the buildings than it was to fix them. It was cheaper to raise and rebuild than it was to go in and mitigate cracks through axially, I've had that problem with that word forever, axially loaded columns. But again, there was a ton of research, and we have much safer connection designs now for earthquake zones, right? The other thing is we need to give you guys safe spaces to fail. So these are all Edison quotes because, you know, he's one of those guys you go to. You know, I've just found 10,000 ways that will work. The 99% perspiration. It's so true. My kid is really creative. My kid is not getting the grades he should be getting in school because he's like super creative and not doing the follow through work. We're working on it, you know. He's 13. We'll get there. But I love this one. Our greatest weakness lies in giving up. And one of the things, there was a great study that came out of, actually Robin Adams was in on this one, who I believe Dr. Landy knows. But it looked at the difference between expert and beginning designers. And one of the things that beginning designers do that expert designers don't is they find a solution that works and stop. It works, it's good enough, right? But are there solutions that are better? Are there solutions that are innovative? Are there solutions that solve parts of the problem that we didn't define originally? Right? How am I doing on time, by the way?
So it's 2:38 and we go until 2:50.
Outstanding, okay. Scamper, to run with quick light steps, especially with fear or excitement. But Scamper is a method that was developed to get you to think about different ways to relook at problems. Okay, and I will make all of these slides available to Dr. Landy if anybody wants copies. But one of the things I've done with the Scamper exercise is think of your cell phone, and can you modify your cell phone by changing the meaning of it? Like, what does it mean to have your cell phone? And that's been going on for, what, 15 years now? The iPhone has so totally changed the meaning of what a phone is. It's a laptop in your hand these days. You know, can you remove things? Can you rearrange them? Can you adapt them? There's also, I don't really have this. Yeah, we're not going to do that one right now. But there's the Sternberg propulsion theory of creativity, but it looks at how people develop solutions to things. So my particular niche in creativity is pulling from sources outside of like the normal discipline. So I have a degree in theater. I'm a Lego freak. I love going to Disney. I've traveled all over the place, and I'm just a bit of a dilettante when it comes to the things that I like. So when I think of solutions to things, I don't think of pulling them from the discipline I'm in. I think of them from like 900 different directions, right? And you can take something and completely flip it around, right? What if we took an item and just completely turned it around to change the concept of it, take some of those ideas and now add it back into the original, right? So there are different ways to get your creative ideas. I think back when we had the EPICS program, Bill Oakes was telling a story about a project that one of the groups was doing, and they needed a heating element, but everything they had that they were thinking of would get too hot. They needed something that would get just hot enough, but you could still like touch it without completely burning yourself. And one of the women in their group went, a straightening iron. Right? You're not burning your hair off when you use a straightening iron, right? I'm not seeing any of you here who probably own one, but anyone whose hair is long enough, I'm thinking. But you need to be able to do this and get it. So you've got a heating element. So they started looking at basically personal health items for what kind of heating elements they're using to solve the problem. But you have to be able to think outside of, we're doing this mechanical engineering project to do that. So these are, this is just an ancient bit of advice, but there is no right answer. There are correct solutions to well-defined problems, but there are no right answers in engineering. Avoid ambiguity. You're going to have to start getting a handle on ambiguity. It will be a good chunk of your professional life for a while, and you'll hate it. Right. Play is frivolous. Oh yeah, right. That's why every company that everybody wants to work for now has it's become an actual like meme or satire in movies that there's a basketball court in the middle of the office kind of thing. That's not my area, or even that's not my idea. Right? No, you don't steal other people's ideas, but you can get the essence of that idea and adopt it and modify it, and if appropriate, give them credit for it, right? but you will have to work out of your area of, out of your comfort zone when you go to work. First thing I had to do on, for the first architectural engineering company I worked for was develop a foundation. Now, when I learned foundations, it was column, square footing, axial load. Okay, maybe a little bit of moment. Right, we could deal with this. This one was retaining wall, retaining wall. All right, this retaining wall had heights from here to here of soil on it, causing it to have a moment. There was a ramp in the middle that changed elevations, and the retaining wall over here had differing levels of soil. So I had an infinite number of cases of moment and axial load on this footing, and I'm like, right, and this was before there was software to do this sort of thing. I don't think I've ever reinforced anything with that much rebar in my life, but you know, you take what you got and you roll with it. Okay, communication. You have no idea how much this stuff bothers me. Because I know how to use 3 versions of 2 and 3 versions of your, you know, all of this. I once asked a group of students why, if they knew why I wouldn't buy the magazine Real Simple. It's grammatically incorrect. It's really simple. You use adverbs to modify adjectives, not other adjectives. And I cannot buy the magazine because of it. Honest to God. Doesn't mean you don't have to, but I don't know that it's your magazine anyway. But this idea that we're engineers, we don't have to talk good is absolute garbage, right? It will destroy your career. If all you want to do is sit in a cube and run numbers for the rest of your existence, knock yourself out. But I had the first year I was here, I had someone come interview me from their tech comm class, and they asked how much of my time I spent writing and communicating at my job, and I went, 80, 85. And I wasn't kidding. This is actually a great t-shirt because it takes engineering terms and translates them into basic English. One of my other pet peeves is, oh, my professor's so smart, except they're so smart they just can't make it, you know, they can't make it understandable. It's you know, they can just knock this stuff out and it's really complicated, but they're so, no. Smart is being able to take that complicated concept and making it understandable for people. If you cannot communicate that complicated concept to someone and make them get it, then there's a problem. There is a competition every year called the FIRE competition. It's run by the Alan Alda School of Scientific Communication at Stony Brook University. Alan Alda, for those of you who are too young to remember, was an actor who played Hawkeye Pierce on MASH. And, oh my God, they're even too young for the West Wing, aren't they?
Probably, yes.
And Scientific American.
Oh, jeez, okay. So anyway, Alan Alda was an actor, but he realized that there was a problem. Oh, yes, he still is, actually, yes, that's true. He donated a lot of money and time to start this school for scientific communication. And one of the things they do is the flame competition. And it is a competition to develop essentially a video that explains a complex scientific concept, such as what is a flame, so that it is both scientifically accurate and understood by a 10-year-old. One year it was what is sound. So if you ever get an opportunity and you're feeling really frisky and want to try out your comm skills, go check it out. But this idea that this is also particularly important when you're working in multidisciplinary, interdisciplinary, and or transdisciplinary groups. I've done most of my research over the past 8 to 10 years has been interdisciplinary at a minimum. And what I found is that I absolutely gravitate towards working with people who are willing to learn my dictionary and whose dictionary they're willing to teach me, because it makes an incredible difference. And whether or not they're the best in their field is secondary to whether or not they're the best people who can work together. Good teams really matter. And then, of course, there's this fabulous old joke, which is, you know, what the customer really wanted versus how they explained it, how it was envisioned. I like the analyst is my personal favorite. Yes.
Gotcha.
Write everything down. Oh, yes. So I'm like, why do I have this slide? My husband's an atmospheric scientist. For me, these are wind loads. Right? There's something that hit a building. To him, they're environmental forcings. Took us a year to figure out we were talking about the exact same thing. So even in the same household and in scientific fields, you can have different names for things. So when you're working with people, take the time to get to know what they mean by things. Ask questions, don't be embarrassed. Explain to them what you're talking about. My advisor and I went around for 20 minutes about the solution to a problem that was on one of his homeworks. And we were saying the exact same thing, and we're not listening to each other at all. So, okay.
So Andrea, we had like 2 more minutes.
Okay, so I'm just gonna get through most of this. Actually, so conclusions. This last one, and this is me. It's the world's problems will not be solved by engineers, but they will also not be solved without engineers. We're necessary to the process, but there are other people who have skills who are also necessary to the process. It's typically better to have a qualified team of individuals who can work together than to have the most highly qualified individuals. And that those stereotypical traits that we get stuck with, rarely are true. You know, how many true Dilberts do you know? Don't answer. But are they too young for Dilbert too? Am I just aging out of being able to present? But that and the other thing, we don't learn from our successes. Or as my husband puts it, you don't remember the things on a test you got right. So I'm not going to say go purposely fail, you know, but don't look at failure as necessarily final failure. It's always an opportunity to figure out, okay, now what? Right. And then I love this quote because it's this fabulous inspirational quote. And Sam Baggett was actually completely just, it's really a downer if you put it in context. He's really talking about just failing completely in life. But out of context, it's absolutely brilliant, which is never tried, ever failed, try better, fail again, fail better, and then try again. And then my old colleague, Doug Cleary, who I was in a class with and then TA'd for, I will end with his comment, which is any questions, comments, or movie recommendations? Or do you just want to get to cookies?
Well, I haven't yet seen it, but there's a Muppet movie that or special that's set around Halloween that is posted now on one of these streaming services. I've heard good things.
Muppet Haunted Mansion.
That's what. Yeah,
It's on Disney Plus. Yes, haven't gotten to it yet, but
So let me ask a question.
okay.
So creativity is an important part of engineering.
Mhm.
Where does it appear in a curriculum, or where should it appear in a curriculum? I know that industrial engineering has a 1-credit class called Creativity and Innovation.
My recommendation on allowing creativity in the curriculum basically comes down to having more having more opportunity, again, safe spaces to fail. So that was one of the guiding principles of ethics, actually, was that we were giving people a safe space to fail. All right, the projects didn't have to be done in 6 weeks. Another one is spending more time on having students develop the problem or spend more time, dedicate more time to having students define problems as well as come up with solutions. Because so many of the problems we give you are really well defined. Or they're ill-defined, but they're ill-defined with a lot of constraints. You know? We really put that little package together for you. We don't make you think about all of the other things that could come into play. So spend more time on problem development. More open-ended problems. I say this knowing full well they're absolutely a PETA grade.
That was my next question.
You get an A, you get an A.
You get an A.
Hey, I'm liking this idea better all of a sudden.
Well,
All right, you get a B.
the other thing is, instead of focusing on the answer, focus on the process. So my GPA would have been better in grad school if I'd had one class where it wasn't, no, you forgot the negative on the answer. Because I do that a lot. And yes, it's important, but we have people who check things. We have checks and balances in engineering, but the process and how you go about doing things is as important as a student as whether or not the answer that pops up matches something in the back of the book.
So this is a good stopping point to thank Dr. Surovek for a round of applause.